Hello there. Today we are gonna look at problem 152. This is maximum product summary. Okay. Given an integer array nums, find the subarray that has the largest product. Return the product. Subarray here means that a subarray is a contiguous non-empty sequence of elements within an array. The test cases are generated so that answer will fit in a 32-bit integer. Alright, so we are given int array nums. Now you like to return largest product subarray. Actually, just the largest product. Or subarray. Right, now let's look at the example. I think the problem description is very clear. So example 1, we have 2, 3, minus 2, 4. So the largest product of subarray. Let's try with a brute force approach for now. So if we start with 2, say I'm gonna put a left and right pointer. So if left right is here, actually if there is just one element, then there is no product at all. So let's try with left right here. Now this will give us 6. Left right here, this is minus 12. Left right here, this is minus 48. So if left is at the second element, this would give us minus 6. Left right here would give us minus 24. And then the last one, third and fourth element, we would take minus 8. The largest product of subarray is 6, which is correct. Okay, now let's look at the second example. We have minus 2, 0, minus 1. Left right here, we got 0. Left right here, we got 0. Left right here, we got 0. So the largest one is actually just 0. So 0 is the answer. Result cannot be minus 2 because, yeah, I understand that. So subarray has to be contiguous. I think I got the problem now. I think I understand the problem description. May I ask a few clarifying questions? So clarifying question 1 is what is the length of the array nums? So the answer is it is between 1 to 2 times 10 to the power of 4. So there is at least one element. And then the range of nums itself, the values in nums, I think it doesn't matter that much. So I think it doesn't matter that much. At this point, I believe we have all the necessary information to move forward. I would now think of some possible approaches to solve this problem. So if we use a brute force approach like we did above, that would take us n times, it would be n squared complexity, because left and right could be any could be at any point. So I would like to, I did observe a few things when I did the examples above. So let me write down the findings. Findings 1, if there is 0, we might as well. So if whatever we multiply with 0, we will get 0. So that is a fact. And it means that if we are given a subarray and then there is a 0 in the middle, we might as well split them up into two different array, and then we take the maximum product of each array. So that's kind of a minor divide and conquer approach. So if 0 in nums, then all we could do is we could just take the maximum of nums split up at I. So f of nums, this is equal to max of f of nums, but we divide it into two subarray. Okay, so that is one findings. Now another thing that I noticed is that the negative value does matter. So if we have a large negative value multiplied by a small, it doesn't matter if there is a negative, as long as it's a negative, then we flip the value into a large positive number, and that number is positive. It is possible that that could be our answer. Okay, I think to make it more clearer in the finding 1, the solution itself is the max of the two sub-solution, or it could also be 0. Right. Okay, now how are we going to do this? So as I mentioned before, we could take the negative value, take a negative value. If we take two negative values and we multiply it together, then we get a quite large positive value. And one thing that I noticed when I did the example 1 is that there are some repeated calculations that I did. For example, when I calculate the product of first element to the last element, you could actually break up the problem into a smaller one. For example, so f of nums is actually equals, sorry, if not s, I'm gonna define a p as product. So let me define p of nums as the product of nums. So if we look at the previous problem, when we do p of 0 to n, it is equal to p of 0 to I times the p of I to n. So if we know the POI and PIN, then we just multiply them together and then we get the solution. And thus, the calculation itself, we don't need to go through, we don't need to waste our computation to go through computational time to go through all the array from 0 to n to compute the product of 0 to n, if we know that we have done this calculation before. So given this, I think we can do memorization. Based on these findings, we could do a memorization. So overall, we still go through we still got the ON squared. And the area will get ON squared complexity because we need to consider our possible combinations. And then if there is a 0 in the array, when we split them up, it actually optimize our code further. It's not much, I think, because if we just look at the array with zeros as a single problem, then all you could get is say you would get like a n times n minus 1 over 2. But if we split them up, let's say into n half of n, so n over 2, then the complexity will become n over 2 times n over 2 over divided by 2 times 2. So it would be n squared over 4 instead of n squared over 2. It's just a very slight optimization, but I think it is interesting to explore in this problem. Yep. So I think that is one approach that I can think of for now. Does this sound reasonable to you? I think I would like to go through like the example again based on what I described. This is mainly about the findings in finding 2 that I jot down here. So if we go back to example 1, we have 2, 3, minus 2, 4. So if we do it like a first and second element, then we'll get 6. Second and third element, this would give us minus 6. Third and fourth would give us minus 8. And then we consider subarray of length 3 element. Then it would just left and right here. So here we could use the previous computation we have come up with. So this would be 6 times minus 2, and this would give us minus 12. Then if we move it from second to last element, then this would be minus 6 times 4. Now this is a small array, so we don't see much optimization there, but it will help us in the if the size actually grows bigger. This gives us minus 24. If we consider the whole array, then they would give us, say, minus 12 times 4, so minus 48. Okay. So the answer here would be 6. Can we do it much better? Say, so this is ON squared solution. Curious if we could do better than this. Can we do it in ON? So I would like to spend some time on this. In ON, how are we gonna do that? So if we split up the problem, as I said, even there is 0, if there is 0, then we basically start over at the next element. Correct. But then how do we know? So I think we can do it in ON. If we just consider what is the largest positive and largest negative so far. Because all the numbers, okay. So let me add another findings here. So product of if the length of nouns so because the nums I are all integer, given nums I, these are all integer, then the product of, if we are given two array, so let's say n, m, then this means that the product of n actually let me write it down more carefully. So P of I to j, this will be always smaller than or equals to P of I comma j plus 1. Right? Because if we just have an extra element, then we could either ignore it, or we could also include it into our solution, and that would give us a larger product, right? So now, based on this, I think this could further optimize our solution, because now we could just consider at any point okay, so I think I got some idea here. So the idea is that I will define me of I'm trying to come up with a better naming here. So how about okay, let's do it positive and negative. I'm going to call P of nums is the largest product of nums, and then n of nums, this would be smallest product of num. Actually, we cannot do it this way. Can we do it this way? Okay, let's try that out. So in the first example, we have 2, 3, minus 2, 4. So P and N. Positive is 2, and then 6, minus 12, then minus 48. So what is the largest here? So negative smallest product of nums is 0, 0, and then largest positive here is actually 0, or it could also be here, it should be say 4 and 48. So positive is it's actually just 4. Yeah. I think we can do it in ON. So from here I got some idea. So the positive of I, Pi, is equals to max of the nums I, or it could also be P of I minus 1 times nums of I, or it could also be the negative of previous one times nums of I. So we just do this repeatedly. And therefore negative I is the same, except that we are using negative here. So nums I, P of nums I, and nums I. And then as we move along, do I need to check the zero here? I think that is, do I need to consider zero when I compute the max and min here? I think that's a good question. Okay. I think if we don't do this, then it's possible that our answer is gonna be I think we don't need to. But one thing that we could do so P0 and N0 is, we can initialize it to 0, so that when we check it, the max and min would work. Okay, and then as we move along, we will get our answer. So this way, we are gonna keep on updating the positive and negative to a larger value. And how do we know when we get the maximum? Okay, so here it is. We could initialize the solution as a maximum of p. But pi could be 0 all along. So what we're gonna do is Okay, f could be, hold on. We could initialize as f to the first element, and then as we move along, we could check whether the positive has grown larger. And the p cannot be 0 unless we got the 0 there. So what we could do is we take the max of norms of 0. Okay, actually the solution, we could do the minimum. So the problem that complicates it is that we have a 0 here. Okay, how about we just start with the norms? Sorry. So instead of p0 at 0, we initialize it to the norms of 0. So if we go back to our problem, we do 2, 3, minus 2, and 4. Then p and n, what we'll have is we start with 2, and then positive would be 3. So the multiplication is 2, and then here we would consider say 3, 6, and 6, which is 6. And then here's the same thing, we consider 3, 6, 6, which is 6. Actually we take the minimum. Let me just write down this more clearly. Okay, let me done it from top to bottom instead. So p and n, we start with 2, and then we consider three, and then 6, 6. So positive would be 6, negative would be 3. Now when we have minus 2, it would be minus 2, or it could be 6 times, actually minus 2 times 6, so minus 12, or minus 2 times 3, minus 6. So the maximum here would be minus 2, and the minimum is minus 12. Then we move on. It could be 4, or it could be 4 times minus 2, minus 8. 4 times minus 12, minus 48. Maximum is 4, minimum is minus 48. So the answer here is 6, because that is when we reach the maximum. Now let's look at the second example. We have minus 2, 0, and minus 1. So we consider P and N, initialize it to the first element, and then now we go through all of it. So we start with 0, comma 0, comma 0. Largest positive is 0, largest negative is, smallest negative is 0. Now we have minus 1, so we have minus 1, 0, 0. Largest positive is still 0, largest negative is minus 1, so the answer is 0. Okay, I think this will work. I like to start. I think I'm pretty good about this. May I proceed to programming unless there is a further optimization that you would like me to explore. Alright, I think we can move on to coding. I think it's about time to move on to coding. So first of all, I'm going to initialize P and N. Sorry. So P and N are initialized to the first element. Then now it is time for us to go through the rest of the nums. So for N, for num in nums of the, we skip the first one towards the end. So there are 3 elements here that we need to consider. First one is num, and then nums times. Okay, let's go through it. So P would be the maximum of num, or it could be num times P, or it could be num times N. And then N could be the min of num times P, num times N. Actually, let me just create a list instead. So the outcome is gonna be num times P, num times N. P N, this would be the max of outcome, and N would be the min of outcome. And then I'm gonna call the solution as F and then initialize it to the first element, same as the P and N. And then I would set F to be the max of F, comma P. In the end, we just need to return the F. Okay, now then. Alright, now let me quickly walk through the code to make sure I haven't missed anything. In the beginning, I'm going to initialize the solution to the first element. Positive and negative are also initialized to the first element. And then I will look through the rest of the array. And as we go through the array, I'm going to compute the max and min. So the max would be the maximum between the num, meaning that we start from the current element, or we could take the previous maximum multiplied with the current number, or it could also be we take the negative value and then multiply with the current one, it could give us a larger positive value. And then same for the negative. And then in the end, we just check the end of each loop, we just check whether the current positive is larger than what we have seen before. If so, then we update it. And so that's completes the code. I think it's good. Let me now test the code with this our input example. We have 2, 3, minus 2, and 4. We initialize p and n to 2. Solution is also to 2. Now we consider 3, 6, 6. Then we get the 6, and the negative is 3. As we go along, we will see minus 2, minus 12, and minus 6. So we got minus 2 and minus 12, so on and so forth. Then we got the answer is 6. Okay, so I think this should work. Now let me code this out into a LeetCode and try to submit it. So we have fpn equals nums of 0 for num in nums. First, the second element towards the end. Outcome could be a num or num times p, or it could be num times n. Now p and n, this would be the max of outcome and the mean of outcome. So on and so forth. Don't forget to update our solution. F is max of f and the current max maximum positive. At the end, we could just return f. Alright, let me try to run this. Hopefully this is the correct solution. And we got the test case correct. Let's try to submit it. Yep, we got it correct. I think we are pretty safe on the complexity side because this is ON solution. One thing I would like to try is to use a list instead of a tuple. I wonder if this makes a difference. Yeah, now we fall into the majority, but somehow the memory is much better. Is it just luck? We can try to submit it again. Okay, so it's jumping around, so I guess I'm about the average here. I'm curious how others handle this, so let's look at some of the solution. Pre and self result and I think this is what I'm doing too. Is it? But it looks a bit different. It's using prefix and suffix. Is it? Prefix is nums of I. Then suffix is nums of n minus 1 minus I. So that means think this is a bit confusing. Forward. I guess it's doing a forward and backward. Forward 0, then we make it 1. Answer is maximum of forward, backward, and answer. Answer is initialized to minus 10 to the power of it, so it's minus infinity. Then we try to take the maximum. Forward we multiply. Okay, so they got it. So it actually can be split up into 2 for loop, but it combined into 1. So that's why it's a bit confusing to me. Yeah, I think this work too. There's a bit harder to come up with. So it's trying to multiply, trying to take up all the elements. So it keeps on multiplying. Yeah, I think this makes sense because if we have a bunch of positive and negative, we could incorporate all the elements from the first element towards the end. So forward here means that we take up from the beginning and then we try to expand it to the rightward in the rightward fashion, and we try to get the maximum if we start from the starting point towards the end. But the backward here, it tries to explore. If we take it from backward from the back as a starting point, then it means that we could ignore the first element, the second element, third element, so on and so forth. So this is the backward and forward. Yeah, I think it makes sense to do so. I guess it's another solution. I think it's much neat than what I did here. Although it's a matter of perspective in some sense. So I guess we will stop here. Thank you everyone. The solution is, I think it's the same. It's still ON complexity and O1 space complexity. Yeah. So thank you everyone. Actually in here we can analyze the complexity. So let's try to do this. Server is busy. Okay, I guess we will stop here. Thank you everyone.